Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, welcome back again in our series videos of VisualFOAM. So in this episode, we're going to make a mesh of Cyclone separators using VisualFOAM. So before we start our meshing process, there are several notes that we have to pay attention. So number one, remember that for the Cyclone separators case, the fluid domain will be inside the cyclone geometry. So because the fluid will flowing inside the cyclone's geometry. And number two, in this case, we should determine the boundary surfaces of all that forms the cyclone geometry. So it's simply we have to determine all of the boundary surfaces that forms the geometry of the cyclone. After we determine the boundary surfaces, the next step is we have to require a number of surfaces, and of course in STL geometry file format that forms an enclosed geometry according to the boundary surfaces that we have determined in the previous step. So these three information is very important. And now this is our cyclone geometry. So we have four boundary surfaces that forms the cyclone geometry. The first one is inlet here. The boundary surface is inlet here. The surface of inlet flow, the flow of the mixed particles and gas that flowing into the cyclone geometry. And number two is the gas outlet, where the gas flow will flowing out through these surfaces, through this top surface here. So that's why we name it as gas outlet surface. And number three is the wall. So most of the surface here are the wall, of course. Here as the wall boundary surfaces. And the last here is in the bottom of the geometry cyclones. This is the particles collectors. So we will name it as the particles collectors. So overall we have four boundary surfaces. So now let's start our meshing process using VisualFOAM. So usually we open the visualfoam.com and we enter the case name, and I will name it as cyclone case, my case name. So start foaming, and now the first step is we should provide the STL geometry that can form the geometry of the cyclone separator. So remember that we need four STL file format that can forms the geometry of the cyclones. So each of these STL file formats is the boundary surfaces. So we have wall, inlet, gas outlet, and particles collectors. So here I have provided the STL file geometry, and you can download from the link in the description below. So here we click the import surface here, and okay, we browse the locations of the STL file. I located the cyclone's STL here. So we have four STL file formats. This is the inlet, outlet, gas, outer particles, and wall. So this four is surfaces in the forms of the surface geometry. So for example, I'll click the wall here. Okay, this is the wall, right? It actually is very small compared to the initial box mesh, but we only import the wall only. We still need to import the inlet, outlet, and the particle collector. So continue to click here and import the outlet gas. Okay, and again import the outlet particles, and the last is import the inlet. Okay, perfect. So far we have import the 4 STL geometry file: wall, outlet gas, outlet particles, and inlet STL. So now we see that the size of the cyclones is smaller than the best mesh, but don't worry, we can adjust the size of the block mesh align with the cyclone geometry mesh. You can click mesh and click the block mesh here. We just click the fit size here, and it will automatically align with the size of the cyclone geometry. But here I will round this the size of the block mesh. For example, here for the sample here, the maximum x directions of block mesh, instead of 0.0556, I will round it to be 0.056. Okay, and then the next is here I'll make it to be 0 because I round it 0, and here I'll make it from the 0.0678 to be 0.068. Okay, perfect. Now the next step is we have to adjust the number of cells here. I'll make the x numbers of cell of x direction. This is the number of cell of y direction, and here the z direction, and we can see the z direction, x direction, and y direction through these reference coordinates here. So x I'll make it to be 20, and in the y direction I'll make to be 5, and z direction I'll turn into 20 also. Now take a look, the size of this cell is quite appropriate. Okay, now next step is determine the boundaries. So here we have to determine the boundaries of the block mesh. So here, for example, x min, the x minus surface of the block mesh is this side. So this is the wall, of course, this is the wall. So change to be wall. Actually, we can type custom by ourselves. For example, here I'll make it to we type by ourselves, wall 1, for example, wall 1, or yeah, maybe wall, or I'll make it cyclone wall. Yes, cyclone wall. And the x plus is, I'll make it the same name. I just copy that and paste here, cyclone wall. And don't forget to change the type of boundary, because this is wall. We also have to change to be wall, and of course here to wall also. And the y minus is here coincide with the particles collector surfaces. So I also make it as a wall with the name as particles collectors. Okay, here. And the y plus here is coincide with the outlet gas. So I'll make it to be outlet gas. And of course, this is not wall. We have to change to be patch. And the z minus is it's wall actually. Here's z minus. Yeah. Of course, it's a wall. So name it with the same name, cyclone wall, and make it as a wall type boundary. And the last is z plus. Z plus is coincides with inlet of the flow. So we make it as an inlet, and we change the type boundary conditions to patch. So now we finished define the boundaries of the block mesh. So the next step is in the SnappyHexMesh menu here. We click here, and in general here we let by its default. So we don't have make any change here. Move to the geometry here, and this is very important. So we click the wall here. So the note says that enable refinement surfaces and disable cell zone to mesh geometry. So to form this mesh of a cyclone separators, we should activate the refinement regions. And the wall, to make a smooth and appropriate mesh, I will make a refinement surface for the wall. I'll make it to be level 2 of minimum and the maximum level 2. And of course, I will also make the refinement edge to be level 2 also. Refinement edge and layers. Okay, I activate the layers and I'll left by the default of the setting of this VisualFOAM. And the next is outlet gas. Of course, don't forget to activate the refinement surface. And I don't make any refinement surface for the outlet gas, so I just make it into the as default. Okay, and yes, and okay. Next is outlet particles. Also, I'll just activate the refinement surface without any make any refinement. And the last is inlet. Of course, also just make the refinement surface without any refinement surface level here. So I'll left it just by its default, the 0. And after that, we move to the castellated mesh here. So here, this is very important. The locations in mesh. What does it mean? So the location means this is the reference point that we use to determine the fluid domain. So in this case, of course, the fluid domain is inside the cyclone geometry, not outside of the cyclone geometry. So we have to ensure that we have to place the location in mesh here inside this cyclone geometry. So the location in mesh here is actually represented by this yellow dot here. So it's initially located in 0, 0, 0 in x, y, and z. X, y, and z. So this is the 0, 0, 0 points. And if we move to be, for example, I'll move to be 0.03. Okay, the yellow dot will move away. And for example, I'll change the y direction to 0.5. Oh, where is it? I think it's too far. So I'll change to be 0.1. Okay, here. Perfect. Now we just have to put the yellow dot through inside the cyclone geometry. So here I'll change to be 0.03. Okay, perfect. Now the yellow dot is placed inside the cyclone geometry. Perfect. Now, so here, okay, the rest of this menu, we left it just by its default. Add layers, mesh quality, okay, make it as a default. So now we're ready to import the mesh, import the case. So here, export case, and we export case, click this button. Okay, perfect. Now we have downloaded the Cyclone case. So here I'll move it to the DC in order to get an easy access for the Ubuntu. Now after we don't forget to extract files and okay now. Okay, this is our Cyclone case. Okay, now the structures of the OpenFOAM simulations. We have 0 folders, constant system, and RM print Cyclone case form. Now we open the Ubuntu and we move to the directory of this case. So it's simply I change the directory to be cd to, because I already in this DC, so I just move to the Cyclone case folders, cd Cyclone case, Cyclone case. Now we are inside the Cyclone case folders. So before we start, I'll prefer to open the alprun.pre files, and I'm using Notepad++. So actually this alprun.pre are consists of commands that we have to run to make our mesh. So here there are 3 commands that we have run each of this command by sequence from the first into the last in our Ubuntu. So I'll prefer to run by ourselves one by one in our Ubuntu. For example, here the first step is we run block mesh. So simply we just copy here, copy the block mesh, and in the Ubuntu we paste it, and we can enter the command. Okay, perfect. Now the second step is run the command surface feature extract. So we run the command and copy that, and okay, pass here. Okay, perfect. Now this is the last steps. So SnappyHexMesh, don't forget to copy and paste in the Ubuntu. Okay, now we just wait until the meshing process ends. But because my computer's not so good, my performance of my computer performance not so high, I think it requires quite long times. So I'll just pause this tutorial video and I'll continue this video right after the meshing process ends. Okay, I'll pause these videos. Okay, actually it's not very long. It's not very long. Okay, here this is meshing process is still running. I think just wait until the whole process of the meshing ends. So just wait. Okay, perfect. Now we are in the castellated stage of meshing process. Castellated. This is castellated, and we can also use see the meshing process in the part view here. Okay, let's see. Apply. Okay, this is the castellated result of the castellated, but I think the snap haven't yet run. So you can see here the geometry is still very coarse because the meshing process have not yet run the snapping process. Yes, it still run the castellated process. Okay. I'm sorry. This is snapping process. Okay, I'm sorry. These iterations indicates that the mesh still on the snapping process. So the castellated process is finished. So the mesh geometry forms the cyclones, but still very coarse. So it required a smoothing process of the edges of the geometry. So that is the snapping process, and the last is adding layers process. So here okay, still snapping. Well, my computer is not so good for my performance. The performance of my computer is not so high. Yeah, so that's the meshing process took quite long times. I just want to show you how if the snapping process is finished. Okay, I think the snapping process is finished. Now, how if we reload files? Okay, perfect. Now the snapping process is finished, and we can see the mesh is formed perfect. Right? Okay, smoothly. The mesh now changed to be more smooth. Yes, smoother. And the last part of the meshing process is adding layers process. I can see here. Actually, still require several minutes. Okay, now we finish our mesh. Okay, alhamdulillah. Now this is our mesh. Oh, now this is adding layer process. Oh, wow, very good. Okay, you can see here also mesh process here. Actually, because we just make level 2 of refinement edges and refinement region, I think the mesh is still quite coarse, but at least we have formed the cyclone geometry using VisualFOAM, and this is the result. So you can see here the cyclone wall right here. Wow, very good, very good. Now, okay, here. Wow, perfect. Now, okay, this is our mesh, and thank you for watching. And please, you can try by yourself to run and make the geometry of a cyclone separator mesh. So good luck and have a try, and bye bye.